Hey guys, welcome to Bar Z. My name's Stan, and today we're going to work on the bandsaw. We had the bandsaw go down yesterday, and this is the idler wheel where the actual saw runs. There's the shouldered part of the wheel, and we have a bad shaft. As you can see, that's badly scored, and there's a bronze bearing that fits on there, very worn, and even the where this bearing goes into here, it wallowed around in there and actually hogged out the cast iron. It's a couple thousandths over. I've already measured the inside of this, so our hole in here is damaged, the bearing is bad, and the actual shaft is bad. And I've already made a shaft. I've already duplicated that. No big deal. That's a pretty simple part to make. This is a 3/4 shaft, but what we're going to do is there's a lot of side load on this thing, and that's why you see the shaft worn here, and look at there, nothing, it's pristine. So a whole lot of side load. We're going to go ahead and go with a ball bearing type insert. This has got a rocker. This fits in here and then just gets pinned right here. A large roll pin gets snapped through there. So I'm going to drill that roll pin hole. Here when we're doing the, who's dinging me? Tom Zalickman. Everybody say hi, Tom. Go over and see Tom at Inspiration Metalworks. Anyways, I need to control my depth before I drill that hole. This was coming out 180, or no, 1 inch 800 thousandths out of here. So that needs to be a very controlled depth, drilled pin. But I'm gonna wait and get my bearings in there first, figure out my thrust and where everything sits. But this is gonna need to be bored. That's a pretty nice fit. Love those piston fits. This is gonna need to be bored. We don't know what kind of bearings we're gonna get yet. This is a 1 inch OD, 3/4 inch ID. That's a pretty tiny bearing. You know, if I get a bearing, it's like this big. So that's not a heck of a lot. So this is going to have to get opened up. This boss is going to get opened up for a larger OD bearing. We might find one with a slightly smaller ID. Probably have to go with a metric, and we'll have to trim the shaft down. So we don't know what we need yet as far as the shaft size or the bore size. So let's go over to the bearing house, see what's available. I'm looking for flanged bearings is what I'm going to try to get a hold of. So let's head over to the bearing house, see what's available, and we'll come back and get to boring this thing. Okay, well, as luck would have it, the back side of this wheel has got an index surface. This has been machined all the way around here, and I've kind of stoned it down, knocked all the high spots off of it, cleaned it, got the dirt off, and I've dropped a pin in here, and this is slightly oversized, so it actually fits the hole very tightly, and I can grab an index off of that. I'm going to set it down on 4 parallel blocks on that surface. The reason I'm doing it this way, it does not fit in my lathe. It's too big of a piece to fit in the lathe. And then we're just going to come in with clamps here on 4 sides and clamp it down. Then we can move the table around and get zeroed up on that pin. We're going to indicate on the OD of this pin, lock our table, lock all our axes, and stay on center and get a boring head in there. So that's a setup for this. After we do this center, if we want to true up this outer, we can get it on the lathe. The part will swing, but it won't swing with the jaws grabbing this OD here, because the jaws hang out, and then the jaws will actually hit the bed of the lathe. So we can bore the center, put the center on a mandrel, and come back here and true this up. But this is going to get us close enough to get started, establish a center, and then come back and do this OD. So let me get this bolted up, and we'll do some indicating. Okay, well, we're all bolted down. We cleaned the table, we cleaned our blocks, we cleaned the back of the part. and we're pinned down in 4 places, and we're down tight on all the parallels. So it's as close to being true as we can get it. We're getting ready to bore the center and true up on the center. So let's kind of eyeball this turkey here. Let's bring the table up a little bit. Let's lock the knee just for now. And we're going to get an indicator out here. This is an Indicol Noga hybrid setup, and I'll show you how I use that. And this just kind of clamps to the spindle. What's nice about this is you can use this without removing the tool. The tool can still be in there. So that's a pretty slick clamp. And let's get us just eyeballed 2 different ways here. This is the game Tom Lipton tries to play with his eyeball, just to see how close he can get. That looks pretty good. I'm sure he's a lot better at it than I am. Okay, spindle in neutral. And now we're bringing our little gauge down here. And we're just going to sweep around that OD. Actually, I think it'd be better if I swept down lower. Yeah, let's do that. I like that better. We're going to sweep down lower onto the closer to the bore. Probably more accurate. In case that hole was bored or hogged out, you know, at an angle, you know, the error is going to increase as the farther away you get from the hole. So I'm going to go and indicate down as close to the hole as I can. Okay. All right, so I'm quite a bit off there. Split my error, come 5 thousandths above, and 5 thousandths above. So I'm going to come here and get me to my 5 thousandths above. Yeah, that was a good 20 thousandths off there. Alright, now we're going to re-zero again. This is going to take some time. Zero. Two and a half thou below. Okay, thou and a half below zero. Thou below zero. Thou below zero, and a thou below zero. So I'm pretty happy there. Let's zero up on that peg. One last time, get one last sweep, and we can lock our table. Zero, zero, half thou below. Pardon my head. Half thou below. Okay, so that pins within a half thou of being equal to the spindle. So we're happy, we're locking the table. Let's switch out to a boring head. Okay, and we're back from the bearing house, and this is what we came up with. That is a snap ringed seal bearing. And our sizing is pretty good. As far as the ID, it measures 667, so we have to take a little bit off the shaft, about 40 thousandths per side off the shaft to match that ID as a metric bearing. And then the OD is 1.57 and 1.57, and we got a 1.9 boss on here. So we got plenty of meat to drop that snap ring bearing in there. They didn't have any shouldered bearings, so we're using a snap ring. All right, let me get a boring head set up on here. In the last clip, we were zeroed up on our bore. Now we're going to get this pin out of here. We're going to get the indicator off. I got the table locked, and we're ready to start boring that hole so that these fellas fit in there. All right, so let's get that set up. Okay, so we came up on a final, and these boring bars are always really challenging when you get down to the nitty gritty and you want to start splitting, splitting thousandths and getting down to the tenths. Our fit, according to Machinery's Handbook, was 8/10 interference, and you got horseshoes and hand grenades right here with just plain old dial calipers. But when you get into the nitty gritty, this boring head reads double, basically. It's 50 thousandths per rev, so if you give it a full revolution from 0 all the way back around to 0, you're going to take 100 thousandths out of the part. So if you need to split 1,000th, you have to interpret half increments on this little dial. So this isn't a direct reading boring head. This is it reads on a radius, so it doesn't read directly on the diameter. And so now we're moving on with telescoping gauges. It's a Mitsutoi. These are actually pretty smooth. The Mitsutoi telescopic indicators are pretty nice. I'm going to put it off center here. Center up the gauge on it. Put it sitting in there tipped. I'm going to tighten. And then I'm going to just flip it one time. And just let it cam over center. And let it find its natural center on the way by. Now we're going to take a reading with a mic. I'm going to do this a couple of times, just trying to get an average. Because these are subject to a small amount of interpretation as well. And right here I'm getting 999. So that's I'm right at 9/10, so close enough to 8/10. I'm going to do this 3 times and compare my readings. Center up, off center, tighten, and then we're just going to just cam over one time. Let it find its natural center. Just hold it gentle and let it find its natural center. Don't force it. Just let it find the highest spot. And again, same reading, 9990. There. So 1,000th under, and we're shooting for 8/10, so pretty darn good for a press fit. All right, same drill. Do it again. Looking for repeatability here is what we're looking for. That time was 9989. So you're 1.1 thou interference on that. All right, so I'm pretty happy with that. Ready to take this off. On the outside, face this front and get our bearings in. Then we're going to true up this outer out here in relationship to the bore. So that's next up. We'll see you over on the lathe. Okay, and we've got it mounted on a mandrel, and we're in between centers. I don't have a bench center setup that's tall enough to do something like this, so we're just going to inspect right here on the lathe. And I've already zeroed up on my lowest point. And we're taking a reading off of where the bearing runs straight to where the band for the bandsaw runs. So I'm zeroed there, and this surface is a big jumpy mess. So there's our low, and we're looking at 5, 6, 7, almost 8 thousandths of run out, and we're going to clean that up. Big hole in it right there. So we're gonna clean up 8,000. So that's actually not too bad from what we had to work with. So we're gonna make a cut on this outer and get that cleaned up, and then make a cut on this inner, and true up this wheel in relationship to the bearing where it actually runs. All right, so let's get set up for that. Okay, the setup's done. We've flipped the wheel around, moved it back tight
as tight to the chuck as we can. Got it on the big side of the arbor. I'm using a bolt through here to drive it. I'm going to bring the camera over just a little bit here. You can see where my bolt catches my drive pin. With actually, there's a tie wrap around it to stop the backlash. The wheel's so heavy when you shut the spindle off, it'll slam around to the other side. If it's stupid and it works, then it's not stupid. All right, so we're set up to make the cut. I got the tool post on the back side to gain some extra clearance. And we're going to come in here and take off that, I don't know what it was, 8 or 10 thousandths, or I don't even remember what it was, but we're going to touch off and just clean it up. All right, so let's get to that. So that's not blowing out the camera. Let me do that again. There's your run out on that bandsaw wheel. All right. So one last thing left to do, and this thing's at a close. Okay, well, we got this thing to a close. There's our old shaft. You can see how badly scored it was. And old plain bearing with all of its slop. And new shaft in, and you can see down there how much I took out of it. It was actually about 40 thousandths per side. But now we've got a nice slip fit in here. And that's our rocker. And all we have is a plain snap ring right there, as seen here. So snap ring on, and this machine's back together. Just have to adjust the blade tracking. Our OD is cut and running true. And this thing's at a close. So overall, 2 bearings, and I had to buy a new snap ring. We got 18 bucks into it, but it took me all day. But old machinery never dies. It just goes to bar Z. Okay, we got our new shaft installed with bearings and everything. And now I'm going to show you how to set the blade tracking. And this is pretty important with bandsaws, because you don't want this blade to be run into that fence really tight and wear it out. It'll actually wear out the wheel. And what I've got back here, Mike, can you show me or show them what I'm doing back here? This right here is adjusting the rocker. Right here like this. And if you look at the action and reaction, you can see this wheel actually tilting. So I'm gonna back off, and you can see that wheel tilt down. So the more I move it this way, the blade's gonna try to fall off. And the more I tighten it, the tighter the blade's going to get up into that little fence. I'm going to run it, and what we want to happen is you want the blade to come away from the fence, and then you just tighten that rocker just till the blade just pulls up into the fence. Don't force it in there. So we're going to go ahead and run this thing right here. And I'm going to start backing off. As you can see right up there, you'll be able to see that blade just start coming off of the fence and begin to derail. Right there, it wants to pull away and derail. So I'm just going to start tightening that rocker. And you can see the blade just slowly starting to track back in. And you can actually hear it when it starts rubbing on the fence. Alright, I'm pretty happy with that there. We got a good blade tracking, and our saw's back up and running. Alright guys, thanks for watching.